Hello everyone and welcome to lesson 12 on the Save My STEM Physics channel. This is the penultimate lesson of particle physics and we will be studying today annihilation and pair production. So what are these terms and sort of what role do they play in physics? So I believe we've discussed annihilation before, but annihilation is very simply when a particle and an antiparticle interact, they annihilate. But what does this actually mean? Annihilation is when these two parts, so a particle and antiparticle pair, interact and release energy proportional to the sum of their masses. And we'll talk about the proportionality as well. It's an equation that you'll probably be familiar with. It is E, so the energy released equals mc squared. You've probably seen that equation before. I'd be surprised if you haven't. And so annihilation is, so the masses themselves cease to exist and get transferred into the form of energy. So this kind of breaks our idea that mass cannot be created or destroyed and that energy cannot be created or destroyed, but they can be transferred between the two. So that's why physicists typically, when discussing mass on a quantum scale or on a particle physics scale, will talk about mass energy and not mass, not energy, mass energy, which is another place that this equation comes in. So if, say, we have the mass of an electron, so m e minus, so the mass of an electron is 9.11 times 10 to the minus 31 kilograms, right? And the mass of any antiparticle is the same, so the mass of a positron is the same as the mass of an electron. So again, 9.11 times 10 to the minus 31. So if we go back to this equation here, it's the sum of their masses. So we're going to add these two masses together. Let me just get my calculator. We're going to add these two masses together, and you can't see my calculator screen, unfortunately. But the sum of their masses, so if I just put Me minus plus Me plus, so mass electron plus mass positron equals 1.822 times 10 to the minus 30. And we're going to plug that into our equation. E equals 1.822 times 10 to the minus 30 c squared. C is 3 times 10 to the 8. It is the speed of light. And so if we plug in 3 times 10 to the 8, we get E equals 1.6398 times 10 to the minus 13 joules. We've done everything in the right SI units. That's in kilograms. That's in meters per second. So that'll be meters squared per second squared, and therefore that will be in joules. So that is what annihilation is when a particle and antiparticle interact and release energy. But what is pair production? Pair production is very simply the opposite of this. So if I just draw a line to show that we're on a separate part of the lesson now. Pair production is when a photon of high enough energy produces a particle antiparticle pair. And this again follows the equation of E equals mc squared, but importantly, because we are working with two particles, it's better to think about it as E equals 2mc squared because we're making two particles of the same mass. So the energy required in the photon for pair production is equal to double the mass of any given particle multiplied by the speed of light squared, or the mass of the particle. The mass of each particle produced is equal to E over 2c squared equals m. So we can work with the exact same numbers that we did before. 1.6398 times 10 to the minus 13 over 2 lots of 3 times 10 to the 8 squared equals m, and we will get m equals, I'm just going to plug this into my calculator to see if it's actually right. It should be. Yes, and that will give us 9.11 times 10 to the minus 31, which is the mass of an electron or mass of a positron. So annihilation is when a particle-antiparticle pair interact, and pair production is the formation of a particle-antiparticle pair, or the creation of mass from energy. Thank you very much for watching. The next lesson will be about Feynman diagrams. See you in the next one.